This next record is what our party is all about.
All right, let's do this. So today I wanted to work on some more radical problems for you guys. So see here we got exponents that have fractions, and when you have a fraction, the denominator is the root that you're taking to the number. So you can actually rewrite these. So you have minus 48 squared. That's a terrible 8. So 48 squared, and it's under a cube root. And then you have 9 to the minus 7, and that's just under a square root. So we're still working with radicals. So to start with minus 48, you can actually pull the 2 out from the exponent. So you have 48 to the 1/3, the quantity squared. And you can do the same thing with the 9. You can pull the minus 7 out. So you have 9 to the 1/2, quantity to the minus 7. And 48 is just 4 cubed. So the cube root of that is 4. So minus 4, quantity squared. And then the square root of 9 is just 3. So you have 3 to the minus 7. And that just gives you 16. You can bring the 3 underneath because that's the minus exponent or negative exponent. So you just have 3 to the 7th, and we can leave the answer at that. Problem 2, we can just distribute the exponent through to each term inside the parentheses. So you have x cubed times 1/3, y to the 9th times 1/3, and z to the 4th times 1/3. That just gives you x and then y cubed and z to the 4/3. For this problem, you'll just want to distribute the square into the term with the parentheses. So you have 5 squared, which is 25, times x to the 2/5, divided by 2 squared, which is 4, times y to the 6/5. And that's multiplied by 4, x minus 3/5, over y to the 2/3. So you can divide out the 4s. So you have 25, and then add the exponents for x. So you have x to the 2/5 minus 3/5 divided by y to the 6/5 and plus 2/3. So here you get 25 times x to the minus 1/5, and that's divided by y. And it looks like we need a common denominator, so multiply the left by 3 over 3. So you have 18 over 15, and then multiply the right by 5 over 5. So you have 10 over 15. So you're left with 25, and we'll bring the x down. So you have x to the 1/5 times y to the 28 over 15. Okay, now I'm going to switch over to using radicals instead of exponents. So for this, you can just factor out the root 8 from both terms. So you have 3 plus 7 times the square root of 8, and equals 10 times the square root, and then 8's 2 times 4. So you you take the 4 out, it becomes 2 outside, so you have 2 times 10 is 20 times the square root of 2. On problem 5, we're going to want to do the same thing where you factor out the cube root of 5. So you have 5 plus 8 plus x all times the cube root of 5. So that just gives you 13 plus x times cube root of 5. Okay, for this problem, same thing, factor out the root 9x. So you get 4 plus 5 plus 6 times root 9x. That gives you 15 times root 9x. And then square root of 9 is 3, so you can bring that out. So you have 3 times 15 times root x, which is just 45 root x. Different roots on there. But if you look closely, 16 is just 2 to the 4th power. So you can write 2 to the 4 times x to the 4th underneath the 4th root. And then 8 is just 2 cubed. So you have 2 to the 3rd power x to the 6th underneath the cube root. So you can bring the 2 out of the 4th root. So you have 2 times 10. And then you also get x. And then you can pull the 2 out of here. So you have 2 times 15. And the cube root of x to the 6th is just going to be x squared. So that gives you 20x plus 30x squared. I'm going to change it up a little bit for problem 8. Here we're actually going to do an equation where you want to solve for x. So to start this problem, you just want to square both sides first. So the square root of 10x minus 1 squared equals 7 squared. So that leaves you with 10x minus 1 equals 49. And then add 1 to both sides, and you get 10x equals 50. And then divide both sides by 10, and you get x equals 5. Problem 9, we're going to want to solve for x again. So to start this problem, we can add square root of 30x minus 3 to both sides. And then square both sides, so you get 9x plus 18 equals 30x minus 3. Then subtract 9x from both sides. So you have 18 equals 30x minus 9x. And then we can add 3 to both sides. That gives you 21 equals 21x. So x just equals 1 when you divide both sides by 21. So for this, we also want to solve for x. So add x to both sides. So the square root of 2 plus x equals x plus 2. And now you want to square both sides. So you have 2 plus x equals x plus 2 times x plus 2. So when you multiply these out, just take one term in the parentheses and multiply both of the other terms by that, and then do the same for the next term. A lot of people like to use FOIL, but it's not always applicable. So x times x is x squared, and then x times 2 is 2x. 2 times x is 2x, and then 2 times 2 is 4. So you have 2 plus x equals x squared plus 4x plus 4. And you can subtract x plus 2 from both sides. So you have 0 equals x squared plus 3x plus 2. So to find x here, we're going to have to use the complete the square method. So you just take 3 divided by 2, and you rewrite the problem like this. You do x plus 3 halves squared, and then you subtract 3 halves. And then you have plus 2 equals 0. And the 3 halves is squared, my bad. So you get x plus 3 halves squared, and this gives you minus 9 over 4. And you can just write 2 as 8 over 4. 8 divided by 4 is 2. That equals 0. So you have x plus 3 halves squared minus 1/4 equals 0. And then just add the 1/4 to the other side. And now what we can do is take the square root of both sides. So you get x plus 3 halves equals 1/2. So x is going to equal 1/2 minus 3 halves. So x is just minus 2 halves, which is minus 1. And then we want to check the answer. Square root of 2 minus 1 minus negative 1 equals 2. So the square root of 2 minus 1 is just 1. And then minus negative 1 is plus 1 equals 2. 2 does indeed equal 2, and we're good.